we have to separate given fraction into partial fractions. How we do this? First we have to check the power of numerator and the denominator. In the numerator the highest power is n to 5th power, so the highest power is 5, and in the denominator n to second power to second give me n to 4th power times n squared, so it will be n to 6th power. So in the denominator we have highest power 6 and in the numerator 5. So everything is okay. Next we have to check if we can factorize something in the denominator. We have here n squared and n squared plus 2 in the parentheses. So what we can only factorize, we can check if n squared plus 2 we can factorize. So n squared plus 2 is equal 0. When we move 2 to the right side, will be n squared is equal negative 2. And to second power, and we take to second power and a number, we will get positive number. So positive is equal negative? No. So we don't have real solution for this quadratic equation. So it means we cannot factorize this equation anymore. So this is equal. Now every factor of our denominator will be denominators of our partial fractions. And because we have here n to second power, so we have repeated linear factors, and because the power is 2, it means that from the first expression we will have two partial fractions. The denominator will be n and n squared, and from the second we have n squared plus 2 to second power, so we have quadratic factors, n squared plus 2 to second power. So because we have the power 2, it means we have again two partial fractions from the second factor. First is to first power, we don't have to write, and the second is to second power. And now we need to find the numerators, and in numerator we need to have always the power 1 less than our denominators. First we have linear factor n, so it means we need to have only constant in our numerators. So we have a, so the next will be b. Next we have n squared plus 2, so we have quadratic factor, so it means we need to have in numerator power 1 less, so we need linear expression. So it will be, we have ab, so now will be c n plus d, and again it's square, so we need linear version, so we have d, so now will be e n plus f. We need to find constants a, b, c, d, e, f. So first, to get rid of our denominators, we need to multiply both sides of our equation by the denominator of our original fraction. So n squared times n squared plus 2 to second power. We need to multiply both sides of our equation by n squared times n squared plus 2 to second power. On the left side, denominator we can reduce, and we will have only n to 5th power minus 2n to 4th power minus 8n squared plus 4n minus 8. And on the right side, when we multiply first expression by this whole expression, n will reduce with square, so we will have only a times n squared plus 2 to second power plus, and the second fraction when we multiply by this whole expression, n squared will reduce, and we have only b times n squared plus 2 to second power. The third fraction when we multiply, we will have only cn plus d times n squared will stay, and n squared plus 2 will reduce with square, so we have only times n squared plus 2. And from the last fraction, when we multiply this whole expression by that, n squared plus 2 to second power we reduce, and we will have only en plus f times n squared. Now we have to do multiplication on the right side. First we need to do the power. So let me copy left side. We have n to fifth power minus 2n to fourth power minus 8n squared plus 4n minus 8. This is equal, and like I said, an we have to copy, and in parentheses we will have n to, we have square of sum, so this is first expression to second power, so it will be n to second power, n squared to second power will be n to fourth power plus, next we have 2 times first expression times last expression, so 2 times 2 give me 4, we have n squared, and 2 to second power is 4 plus b, and in parentheses we will have exactly the same expression which we get from this multiplication, so it will be n to fourth power plus 4n squared plus 4 plus, and now first I will multiply cn plus d times n squared, so in parentheses we will have cn cubed plus dn squared, and we have times n squared plus 2 plus, and let me write this here, en plus f times n squared, so it will be plus en cubed plus f n squared. And now left side again we will rewrite, so we have n to fifth power minus 2n to fourth minus 8n squared plus 4n minus 8, this is equal, and now on the right side we have to multiply every expression in parentheses times an, so it will be an to fifth power plus 4a n to third power plus 4a n plus, and now times b, so it will be b n to fourth power plus 4b n squared plus 4b plus, now every expression in the first parenthesis by every expression in the second parenthesis, so it will be cn to fifth power plus 2cn cubed plus dn to fourth power plus 2dn squared, and we have plus en cubed plus fn squared. So now we have to combine the like terms. Let me copy the left side. We have n to fifth power minus 2n to fourth minus 8n squared plus 4n minus 8. So this is equal, and we have with n to fifth power two expressions, so we have a plus c times n to fifth power. I just factorized n to fifth power. Next expressions with n to fourth power, so we have b plus, we have d, so times 2n to fourth power plus, now we have to check expressions before n cubed, so we have 4a plus 2c, and we have plus n cubed. Next with n squared, so we have 4b n squared plus 2d n squared and plus f times n squared. And now with n we have 4a n squared. I just wrote this, only one expression with n, and we have plus 4b. So now left side must be equal to the right side. So coefficient before n to fifth power, we have a plus c must be equal. Coefficient before n to fifth power is invisible 1. Next we have b plus d. Coefficient before n to fourth power is negative 2 on the left side, and coefficient before n cubed, so 4a plus 2c plus e must be equal. On the left side we don't have n cubed, so this is equal 0. Next we have 4b plus 2d plus f. coefficient before n square. On the right and on the left is negative 8. Now, before n, we have 4a. A must be equal 4. And constant 4b must be equal negative 8. We have 6 equations, 6 unknowns. So now we have to solve this. From this equation, 4a is equal 4. It means a is equal 1. And from the last equation, we have that b is equal negative 2. And we divide both sides by 4. Negative 8 divided by 4 is negative 2. So we have a, b. So when we have b, we can find d from the second equation. b is negative 2. So negative 2 plus d is equal negative 2. So d is equal negative 2. I will move negative 2 to the right side, so it will be plus 2. So we see that d is equal 0. And from the first equation we can find c, because we have a, 1. So it will be 1 plus c is equal 1. So we have that c is equal, when I move 1 to the right side, will be 1 minus 1, so this is 0. We have c, d, a, b. So now we can substitute to the third equation a, c, and we will find e. So 4 we copy, a is 1, so we have times 1, plus 2, c is 0, plus e is equal 0. So we have that e is equal, 2 times 0 will be 0, and 4 times 1 is 4. When we move to the right side will be negative 4. So we have e. And from the fourth equation, we can find f. So we have b is negative 2. So we have 4 times negative 2 plus 2 times d is 0 plus f. This is equal negative 8. So we have 2 times 0 is 0. We don't have to write. Is equal negative 8. And 4 times negative 2 is negative 8. When I move to the right side will be positive 8. So 8 and negative 8 we have. So f is equal 0. We found all constants, so now we have to come back to our partial fractions, substitute a, b, c, d, e, f, and we have our solution. Let me copy the beginning. It means our original fraction is n to 5th power minus 2n to 4th minus a and n squared plus 4n minus 8 over n squared times n squared plus 2 to 2nd power. So this is equal, a is 1, so we have 1 over n, plus b is negative 2 over n squared. Denominators we have to copy in our partial fractions. Denominators we copy. And we have plus c is 0, so we don't have to write, because c times n will be 0, 0, because c is 0, so 0 times n will be 0, and d is 0. So in the numerator we have 0, so 0 over n squared plus 2 is 0. So the third fraction we don't have. Next we have e. E is negative 4 times n plus f. F is 0, so we don't have to write, and we have to just copy the denominator, n squared plus 2 to 2nd power. So what else we can do? We can rewrite this, that this is equal 1 over n. Positive negative, so it will be negative 2 over n squared. Positive negative, so it will be negative 4n over n squared plus 2 to 2nd power. This is my solution.